All right, so this is what most of your polar equations of conics are going to look like. R equals, K is a constant, E is a constant, so they'll just have a constant term on the top, over 1 plus E cosine of theta. Now I have a note down here that cosine of theta could also be sine of theta. That has no effect on the type of the conic, it just affects the orientation. If it has cosine, where should it be oriented? Cosine always goes with x. So typically if it's got cosine in it, that means it's going to be oriented with the x-axis or horizontally. If sine's in there, it's going to be oriented with the y-axis or vertically, okay? So if E is greater than 1, it's a hyperbola. So that's kind of the way that I remember that. A hyperbola, think about it in an English context. Y'all know what it is in English? A hyperbola is extreme exaggeration. Okay, hyperbola is extreme exaggeration. So if E is bigger than 1, it's extreme, it's a hyperbola. If E is equal to 1, it's a parabola. And if E is less than 1, it's an ellipse. I don't really have a quick trick for remembering the parabola and the ellipse. If anybody sees one, let me know. But I can help you with the hyperbola. And if R just equals a constant C, then it's a circle. We talked about that back when we did polar equations. R equals C was just the equation of a circle. So we don't have to worry about all this stuff right here. So let's look at some examples. Okay, if this is the polar form that we're given, we've got to determine what type of conic it is. So example A here, we've got R is equal to 3 over 4 plus the sine of theta. If you look back at this standard form right here, it was always 1 plus E cosine. So we need to factor out that 4 so that it's 1 plus something, okay? So here is our E right here. 1/4 is our E. 1/4 is less than 1, so that is an ellipse. You really don't have to worry about the rest of the equation. You're really just worried about the constant in front when you factor it out. So B, if we do the same thing, if we factor out a 2, we've got 1 minus 7 over 2 sine of theta. Now be careful, just because it's a fraction doesn't mean that it's less than 1. 7 over 2 is greater than 1. So example B is an example of an hyperbola. And then C, if we factor out that 4 in the bottom, we've got 1 minus cosine of theta. In that case, it's equal to 1. So when it's equal to 1, it is a parabola. The negative doesn't matter. Yeah, the negative doesn't matter. It's kind of the absolute value. Sorry, I didn't make that clear earlier. The negative doesn't matter. Okay, and then the last one there, R equals 5. I threw that note in there. That is just a circle. Okay, so that covers our 4 types. Now, here's something that you can do. Let's graph these in polar form on our calculator and see if we can observe the shape. So we got to be in radian mode and we've got to be in polar mode. Let's see if our calculators will graph these for us. Okay, the first one, 3 over 4 plus the sine of theta. Make sure you get parentheses around that entire denominator. It's really tiny in there, so I need to zoom in. But I can see that that is an ellipse. Okay, and you do have your calculator on the final exam. So keep that in your mind as well. Okay, yes, it's great if you remember the E stuff, but you do have it at your disposal. But you got to remember parentheses. You got to put parentheses around that denominator there. Now, they're here on my paper just because I didn't go to the trouble of putting it on separate lines. So I'd put parentheses around it to be clear what was in the numerator and in the denominator, but it won't necessarily be like that on the exam. You'll have to remember those parentheses. Now, I can't see anything on this one, so let me go back. Let me zoom standard. This one's a little intense, but check it out. It is a hyperbola. And guess what? It graphs the asymptotes. That X right there in the middle, it actually graphs the slant asymptotes in there. But here are your two curves. Okay, here are your two curves, and it's sine. So notice it's oriented on the y-axis. It crosses the y-axis here. Okay. So there's your hyperbola. Let's look at this one. 4 over 4 minus 4 cosine. And there's the parabola. And isn't that beautiful? We can't graph a parabola like that in rectangular form without doing the positive and the negative square root, but we can do it. The polar form will put it up there. It'll put up the entire parabola there for us. Okay. And then, of course, r equals 5. I could just type that in. And there's a circle. It doesn't look like a circle right there because my window is not square. Zoom square, number 5. Now it looks like a circle. Okay, now it looks like a circle. All right, so I don't really have any